Thank you to Excel, Priyank, everyone for putting this event together, and thank you all for braving the Bangalore traffic to get in this morning. We at Anthropic have been spending this entire week, talking to startup founders, customers in the region, like really just hearing how they're using Claude today, what they want out of the models in the future, et cetera. And we couldn't be more excited to be setting up our presence here and like really embedding ourselves and figuring out how we can best support the next generation of founders and developers in the country. So, as a quick introduction from my end as well, my name is Tanveer. I'm part of the Applied AI team here at Anthropic. I kind of sit at the intersection of our go-to-market, product, and research teams, spending a lot of time with our customers figuring out how they can actually be eliciting the best intelligence they can for their applications that they build on top of Claude. And then also separately working on an internal product research work to improve our models and products, the things our customers care about. So over the last 3 months, for example, I've been spending a lot of time on building our memory system in Claude AI and the MCP directory and other things like that as well. So the genesis of today's talk is going to be just talking about a broad overview of what we as Anthropic are kind of thinking about in our roadmap, the products and the suite of developer features we're providing to make it easier for you guys to be building on the frontier, and then separately, like just some best practices and tips for building agentic applications that we've observed from the wide variety of different industries and contexts that people have been developing agentic applications for. Um, so to kick it off, right, this is kind of like a broad overview of how you can kind of think about the suite of Anthropic's offerings. At the core foundation are our models, which is where we spend a lot of our time, obviously, developing the like most intelligent models we can to provide to developers to build on top of, right? So that we kind of provide models in three classes of intelligence: Haiku, which is like the cheapest, most cost-effective; Sonnet, which is kind of the like everyday workhorse type model that's like strikes a great balance between intelligence and price and latency; and then Opus, which is our largest, most intelligent model historically, that is comes at more of a premium. But as you all may know, right? It's not just about the actual model itself to actually do useful things and build useful products. It's also about the suite of infrastructure and developer features on top of that that can actually make it easier and make it better to build products as well. So that's a big focus of ours, right? So within the API, there we're launching many new features from being able to make it easier to run and write code in the cloud, being able to provide memory capabilities, web search, better methods of orchestrating agents, etc. And expect the velocity in which we're going to be shipping features to increase, especially with feedback from more startups and developers in Bangalore. And then at the very top is kind of just like the suite of like products we also provide like directly as Anthropic. So a lot of you might be familiar with Claude Code, our like flagship coding agent, which is like state of the art and designed to like maximize the intelligence that we're able to get from Claude for everyday developer productivity and all sorts of other use cases. Claude AI, which is our everyday like what's it called, AI assistant that you can use in your day-to-day productivity. And then what we'll be probably mostly focusing on today is the Claude Developer Platform, the suite of actual features around the models that you can use to make it easier to build products. And lastly, it's also worth calling out that we also partnered very closely with AWS and Google Cloud, so you can also use our models like through their services in Vertex and Bedrock, as well as our first-party API as well. To give you an idea of just kind of where our research focus lies, and maybe as far as like clues as to kind of where we're heading here, right? We founded Anthropic with the belief that we want to build the most intelligent models, but we also want to build the most safe models to actually usher in this sort of digital transformation with AI in the most beneficial, safe way for humanity. But we also don't think, intelligence and safety are two things that necessarily have to be at odds with each other, right? To do one correctly, you have to do the other. And we strongly believe this in Anthropic, right? A great example of this would be like our study and work into mechanistic interpretability, which is an area that like we Anthropic are like solely mostly investing in. The idea being, we want to spend a lot of time deepening our understanding of how these models work, reverse engineering them, such that it kind of feeds into other areas of research, and then eventually into commercial products and offerings that would be helpful to basically steer, override the models, understand how it actually comes to a decision when you actually put in a prompt. And then separately, right, like it continues to be a large focus of ours, like basically enabling long horizon agentic tasks and all the individual capabilities that go into that. And that's going to be continuing to advance with future releases of our models. Now, not just from the research point of view, right, from our actual like developer platform roadmap and how we're thinking about the actual suite of products around the models, we can kind of like break down our roadmap into like three categories. One, making it easier for you all to build industry-leading agentic applications. These are features such as like memory, web search, orchestration, etc. The second bucket is how we actually give agents the right context they need at the right time, right? We, as you know, invented the Model Context Protocol, MCP, which is a huge, huge part of the strategy. And we're going to continue to double down on our efforts here just because this is such a critical piece to get right. And we want to make it easier for developers in the future. And lastly, also providing features to make faster and more cost-effective agents. As you know, Anthropic invented the idea of prompt caching in the API to be able to kind of cache your prompts and achieve a lot more cost savings in production. And we're continuing to also double down on the features we can provide there to actually make it more economical to build these agentic applications. As you all know, we recently released a new model, Claude Sonnet 4.5. And to thank you, thank you. And I figured it'd be what's it called? Probably pretty useful for you to kind of dive into the tactical areas in which like the model is actually improved, right? We're always so excited about every new model because the advancements that each model makes in its intelligence and other areas unlocks new use cases that were not possible before, right? So in the first category, right, it's no secret that Anthropic's largest focus right now lies in the field of agentic coding, right? So Claude Sonnet 4.5 now has an industry-leading sweet bench score of 80% or 82%. And this is important beyond just coding or beyond just developer productivity, right? Because beyond just like being able to read and write code, right? To be able to be an effective like almost autonomous software engineer, there's all these other agentic capabilities that are kind of baked in that make the models so much better in a wide variety of agentic tasks beyond just developer productivity, right? So we believe that like the superiority that we have in agentic coding translates to so many other areas that can be non-obvious to a lot of developers as well. So an example of this could be, right, um, you all might be pretty used to building applications with kind of native tool calling, right? So this is just an example of you ask an agent to adjust this financial model based on these latest earnings and internal projections, right? What might happen is you have some MCP servers hooked up and you're going to call some resources and some tools from that server, eliciting that context out. And it's kind of going iteratively step by step like that. And that's kind of how agents, for the most part, have operated up until now. What we're really, really excited for is that like you are bringing in agentic coding into the mix here, in the sense that instead of like kind of just making tool calls directly, you can orchestrate those tools via code, right? And this is like really, really powerful because this is almost similar to how you as a software developer might operate, where you write some lines of code, print some things out to the terminal, and you analyze and iterate. Similar with the data scientists, where you're creating data visualizations, reading those charts, kind of iterating from there. And I like to frame it like this, which would be like for every new tool you kind of add to an agentic system in this world on the left, your capabilities of your agents scale linearly. But then when you're kind of in this world where you're orchestrating this through code, the capabilities scale exponentially, right? Because you can do just so much more on top of like basic arithmetic, data analysis, data visualization, et cetera. That was not just possible through just native tool calls. So this is like a direction that I'm like really, really excited for, that like Sonnet 4.5 uniquely unlocks for developers. And we're also very focused on making this easier within our products as well. Next is longer trajectories. Now, what do we mean by that? Sonnet 4.5 like kind of sets a new standard for being able to orchestrate long horizon tasks. Basically meaning the models can take on more economically valuable tasks and work for longer, right? So when we released Opus 4 back in May, we had like a customer, Rakuten, out in Japan, who was able to basically get Claude in a coding agent code for 7 hours straight autonomously on a pretty large refactor project. Then more recently, Sonnet 4.5, before we released the model and we had customers like testing it out, We had a customer build an agentic harness around Claude that was able to code for 30 hours straight to actually build a full stack application and deploy it into production. And these sorts of leaps and bound in intelligence are just like not just a kind of not just the result of like kind of one new capability baked into the model, but like the summation of so many new capabilities kind of coming together, producing this model. One of the things that like really unlocks this sort of idea of longer trajectories and long horizon agentic tasks is the concept of memory, right? This is a really big focus of our models since Sonnet 4 and Opus 4, and it's only gotten better in Sonnet 4.5. It's almost the idea that you can kind of let the models have infinite context, right? The simplest form of this would be that you give the model a external file system from which it can dynamically read and write from, right? And that's like really important because if you're working on a large task, right, like for 30 hours straight, that would involve processing millions of tokens. And as you know, Claude's context window is not that large. And when you're also filling up that context window, the attention of the model is also quite limited, such that not every token is treated the same, right? So this sort of idea of memory, just-in-time context, context engineering, is something we're just like improving in the model, being able to agentically search unstructured data to pull the right context in, as well as like getting a better intuition of how to actually like what are the important details I should note down for future instances of myself. I'm just talking from the perspective of Claude Sonnet here. A more kind of tangible example of this is if you're familiar with like Claude Plays Pokemon, the Twitch live stream we have running that you can go check out right now on your phone or your laptop. Um, we saw this sort of behavior emerge in Sonnet 4, where we gave Claude the ability to like write to a file system to kind of store its memories. And previous iterations of the model basically just created this like gigantic markdown file where all the memories of tracking hundreds of hours of gameplay just sat in one file. But then starting from Sonnet 4 and future models, what was really awesome, we started to see the models actually like organize their files in a more logical manner. Meaning, like, for example, every route in Pokemon, every new city, every gym kind of had its own distinct folder or file, which just like demonstrates the kind of intelligence that the model has in terms of how it should organize its memories, such that it can keep context slim and only pull the right context it needs at any given point in time. And this is so powerful because in this example that you're seeing here, Claude has been able to keep track of like 64 battles, 12 hours of gameplay, and that scales much larger than that as the game continues. Next is the field that like or a domain that we're really excited about, which is computer use. There's this like benchmark here that kind of demonstrates what's it called the leaps in computer use we've been making here. But we found with Sonnet 4.5, it is the best model we've ever produced for being able to basically take screenshots, you know, click buttons, use your keyboard, like basically interact with UIs in the web in a way that it couldn't before. So like if you've used the Chrome extension or potentially other products that have computer use baked in, you should notice a very large difference in the capabilities that was not possible before. And like we're really excited for this to continue to kind of expand in the future. And the last is kind of like domain expertise. This is something that's improved in this model, but it will continue to improve in future models as well. Um, you know, I think in this model in particular, you know, we mentioned computer use, we mentioned coding, we mentioned long horizon tasks, but we've also seen a lot of material advancements in cybersecurity and financial use cases, as that was a big focus of ours that you can read more about in our model card. And in the future, right, we're hoping to also kind of expand the domain expertise that Claude has in the critical industries that matter most, or that matter most to the products that you're building and the customers you're serving as well. So that's kind of just like a breakdown of Sonnet 4.5. And now we'll talk a little bit more just about how we as Anthropic kind of are thinking about building agentic products and how you can kind of take some of those lessons back to your own day to day. I like to just like, I mean, I'm sure a lot of you all are pretty familiar with like what are agents, what do they do, et cetera, or what can they do. But it is important. I think it's still pretty useful to kind of just like anchor everyone on the same set of shared vocabulary, just so there's like almost no confusion. So when GPT-4 first came out, right, I think the way in which most people were first using these models were what we call workflows, right? And workflows are really powerful because what they were able to do is you basically give the LLM a bunch of tools, you change some prompts in some sequence or some structure. Examples being you could classify an input and then route it to one of three prompts. An example could be you chain like 5 prompts together to get some output, right, in some sequence. And the idea is these are systems where LLMs and tools are orchestrated in like a predefined path. So you define the number of steps the LLM will take to get to the end output. Since Sonnet 3.5, we started seeing what we call agents actually emerge, right? Systems where LLMs are able to dynamically direct their own tools and reasoning, where they maintain control of how many steps and iterations they take to an end outcome. And to kind of break down like what that kind of looks like, this is what we call like the agentic loop, where you give a model a task, it comes up with a plan of how to actually accomplish and complete that task. It's then going to take some actions through tool calls, whether that's querying data, whether that's writing to an external system, etc. And then Claude is able to kind of reflect on the results of those tool calls and figure out what the next best steps are, and then kind of iterate from there, right? I think a lot of people like are very very focused on writing the best prompt for planning, writing the best prompts for acting, taking action in an agentic system. But one thing that's like pretty overlooked in my opinion is like how you actually prompt these agents to actually reflect on that sort of feedback they get in the real world. So a great example of this would be, don't think about just like what are the actions the agent should take to kind of like accomplish its job, but what is the feedback that it actually needs to actually steer it along the right trajectory as it's working on these longer tasks. A great example of this would be if you're a front-end developer using Claude Code, you want the model to be able to also like take screenshots and understand, is the layout of the page correct, and then that's useful feedback for the model to self-correct as it's working on a large full stack applications, and otherwise it wouldn't have gotten that feedback. So um, MCP is kind of the protocol in which agents are able to take action and also reflect and self-correct themselves. Now I'll talk about kind of like the components into what builds or what goes into building an effective agents, right? At the foundation, obviously, is frontier intelligence in the form of models such as Sonnet or Opus. And then building on top of that, right? We like to define like the sort of infrastructure that you build around these models to be called what we call an agentic harness, right? So starting with the most basic building blocks of a harness would be actually giving the model some form of tools in which it can go reach out of its box, interact with some external system, query some data, all sorts of different capabilities, right? This is where you actually like kind of give the model some agency, some control, some agency to be able to go act in the external world. Um, and then if you kind of like are able to implement what we call like a tool loop, just a basic like almost while loop even, you can always describe it as, that's basically as simple as you need to get to actually get you know, an agent really fast and working such that it can start to dynamically direct its own processes. From there, right, it's also really important to kind of invest and manage in all the different series of prompts that might go into your agent, whether that is like the core system prompt of the lead agent, whether that is sub agents, whether that is like workflows you're orchestrating as tool calls, etc. Um, that's where you kind of are teaching Claude some unique domain expertise and giving it the context it needs to actually complete the task it is delegated to and the function it serves. Next is like this idea of giving Claude access to a computer in the form of like file system, being able to run bash commands, being able to write and run code, right? For the reasons I mentioned earlier, right? Code is obviously so useful in agentic systems beyond just developer productivity, right? So giving it access to a file system in which it can like write and read from to use as memory, being able to write code and run that code and kind of iterate on that is very powerful for what's it called, for agentic systems, right? And we call this like this idea just-in-time code. The next building block I'm not going to spend too much time on because there should be some more about this coming out soon. But we're introducing also the idea of like skills almost. It's like the idea of you just want to be able to embed domain-specific expertise in these models in a way which you're not just overloading a bunch of unnecessary context in the system prompt. Um, and this is like, we're really excited about this sort of idea. It's just basically an extension of the file system component, which we'll be sharing more about later. And this also deserves its own 45-minute talk, so I won't go into too much detail right now. And then, those are like the most basic components of building an agent. And on top of that, that's when you can start to kind of build additional enhancements on top of that, whether that is sub agents, whether that is like some sort of deep research mode, which is orchestrating a bunch of sub agents, whether that is like some form of auto compaction, similar to how Claude Code will reach its context limit, compact its memory, and continue working from there. and other forms of advanced memory that you can implement where maybe you included some details in the prompt and some other infrastructure to actually like tell Claude how to structure those files that as it works. Or maybe sometimes like your memory needs to be more scalable than a file system. You might need to actually like implement some sort of knowledge graph or other types of capabilities as well. Now, if I work at Anthropic, which I do, I would probably like look at all of this and be like, I've seen this somewhere before, right? And that brings me to kind of Claude Code, right? A lot of you might be pretty familiar with Claude Code as our frontier coding agent. And if you've not tried it yet, I think you should. It's like insanely powerful. But one of the things we discovered as we put Claude Code out into the real world is just like the shocking breadth of use cases it enables beyond just coding, right? Our financial, our legal teams, our marketing teams, even here in Anthropic, also use Claude Code themselves for all a variety of different use cases, right? And like we're kind of thinking about how do we build Claude Code for everything that is not just coding, right? And similarly, how do we enable developers to also build Claude Code for everything to be able to kind of do what we've done with coding, but for other types of work, such as knowledge work, marketing, finance, so much more. Um, so that brings me to kind of the idea or the concept of the Claude Agent SDK, if that's not something that's familiar to you. The idea behind this was because we realized that, Claude Code was just such a powerful general purpose agentic harness. We are starting to focus and build a lot of our own products at Anthropic on top of the same infrastructure as Claude Code. Basically, the engine behind Claude Code that's actually doing the orchestration, the tool calls, etc. Very, very powerful. And as a result, we kind of want to share the unfair advantage that we have with all of you to be building agentic applications at the frontier very, very quickly. The idea behind this is you can kind of just skip building all this infrastructure yourself and kind of have it out of the box to deploy with your own infrastructure. And we're also planning on providing more and more of this sort of native capability in the cloud and the web, et cetera, in the future. And this brings us to the fact that because you're kind of able to use these sorts of what's it called? This agentic harness, right? You can mostly, as a developer, more focus on your end customer, what you are doing to bring unique value to your customers, and the actual domain expertise that's going to actually differentiate your product, as opposed to all this plumbing that everyone else is also working on. The last section I have here is kind of some tips and tricks that we have for building production-ready agents, right? As I mentioned, at Anthropic, we spent the last year and a half working with a variety of different customers, everything from manufacturing to coding to national security to all these variety of fields. And we think we've seen a lot of different like best practices in terms of what works and what doesn't work with building agents that we just want to kind of leave you with as you're thinking about what's next on your roadmap and what are you going to be bringing to your customers. So to start, right? I like to think about when if I'm like starting to build an agent, um, we at Anthropic have this principle of build the simplest thing that works, and we kind of also give that same advice to any fast startup customers and enterprise customers we work with, which would be you should begin with what is the simplest possible agentic harness possible. So that could be sometimes building a workflow, or that could also be like just a really really simple using tools in a loop, simple while loop, right? Or even just using the agent SDK. And then after you kind of have that solid foundation, right, and you have some evaluations we'll talk about in a second, you should then kind of scale up complexity and scale up capabilities as it actually yields meaningful returns for your customers, for your product, right? So starting simple, then scaling up. The other thing is also just like working backwards from your business requirements to figure out what is the right thing you should be optimizing for, which I'll talk about more in the next slide. And then lastly is kind of the actual UI UX design, right? This is becoming a harder and harder problem to solve, and just something that is always worth you all thinking about, because as these agents are working for 30 hours, right, on long horizon tasks, they're obviously producing a lot of text in the process that can be like cognitive overload for any of your users who are using and interacting with your applications. So how do you strike the right balance between giving your users full transparency into what the LLM is doing, while also being able to not overload your users with information that's irrelevant, right? putting a lot of thought into how you navigate that trade-off is like critical also to driving adoption of your products. The next large failure mode that we've seen with a lot of customers, less so with startups, but still it's like worth talking about, is this idea of implementing evals as like step zero, right? A lot of customers fall into this trap where they take way too long on building these agentic capabilities, building these systems, deploying, et cetera, with that overlooking the basic fundamentals of building good evaluations, right? So it's almost like what you should think of this as is like putting a lot of time into building evaluations is only going to save you a lot more development time down the road, right? As you make any change to your prompt in a really robust and complex agentic system, those even small one sentence, one word changes can always have unexpected consequences that you would not foresee, right? And you need to be able to build robust enough evaluations such that you can catch that sort of behavior that would matter to your customers and your product. And second would be kind of um, investing in the actual like infrastructure around telemetry, observability, logging, because once you actually put an agentic product out into the real world, whether that's with enterprises, whether that's with consumers, right? There are all the ways in which humans or your users are going to interact with these agentic systems that you may not have foreseen, right? So if someone comes up with a new failure case or edge case for the agent in the real world, you want to have that tight feedback loop to actually be able to incorporate it into your evaluation such that you can actually be optimizing for it and evaluating for it going forward in the future. Next is kind of another concept of not just building evaluations, but building the right evaluations is like so important. I think I like to think about this in the sense that there are a number of different coding agents on the market, right? Whether that's Cursor, whether that's Cognition, whether that's even like the full stack development applications like Lovable or Emergent, right? And if you think about the competitive landscape, right, of who is going to come up on top, whose product is going to be adopted the best, it's going to be the one that actually picks the right metrics to optimize for, not the one that's using the best model or using like the most complex agent harness around it, right? So, thinking critically around what is important to my users to optimize for from the start is critical and paramount to actually like beating your competitors in this market. And this is just kind of how business is going to be done in this sort of AI native world going forward. And the other thing I like to think about also, or another example would be kind of in the customer service example, right? If you are building like an agent for customer service, is it more important for you as a business for reducing churn rate to give a faster response that to your customers such that they don't feel like the system is lagging and it's buggy and they're having a bad experience? Or is it more important that the agent is actually taking a lot of time, gathering all the correct information, and like giving the best possible response back to the user? Or is it something in between, right? I kind of like to frame it as there's a sort of like cost triangle of intelligence, cost, and latency. And right now with today's models, it's possible to kind of pick two, but not have all three, right? So starting backwards from the actual business requirements to then figuring out what you're optimizing for in that respect is just the probably the most important thing for any new founder today. Cool. And this is the last thing I'll kind of leave you with for today is just to kind of think about the exponential trajectory of these models, right? The rate of progress is kind of like is astounding. Like even we at Anthropic have a hard time keeping up with everything, every new model release, all the cool new features that you could be using. Um, and just like a year ago we were at this stage where these models were kind of only good enough for kind of being your general purpose assistant, being able to look up documentation, being able to look up company financials, this sort of stuff. But I think this year or since Sonnet 3.5 and especially this year, Claude has kind of finally fallen into this category where it is your collaborator, right? Agents that are built on top of Claude, you can kind of hand off large amounts of work to actually then go and do it on your behalf, right? And like our vision is that like these models will get more and more intelligent, the infrastructure around it will get easier and easier to build with, such that in a few years, like Claude will be able to pioneer, that is creating breakthrough new discoveries in drug discovery and material sciences and all these different domains that are very, very challenging to advance in. So how does that translate to you? Well, I think that the next cursor, whether that's in Bangalore, whether that's in the US, right, is going to be the one that actually is kind of thinking about where these models are heading and building the infrastructure today to kind of actually leverage that future level of intelligence, right? Investing in that in the future. Great example of this would be cognition, right? Back when GPT-4 came out, they built Devin, and everyone kind of criticized them, like back in 2023, or actually rather, yeah, 2023, that this was demoware, like this doesn't work, etc. But then suddenly the models got so intelligent that Devin became so powerful, and it just took off in revenue, right? So think about that sort of exponential of how can you actually look ahead, build the infrastructure now to get ready. If you had a country full of geniuses in a data center, as Dario likes to call it, how would you kind of build the right products and serve your users best around that and start preparing for it today? Awesome. That's all I had for today. Thank you guys so much, everyone.